Today we're going to continue our discussion about simplifying radical expressions, and today we're going to do some multiplying with them. So when you're multiplying two radical expressions, you do not need to have the same thing under the radical symbol. They can be different. Not like the way it was with adding. When you were adding two radical expressions, the same thing did have to be under the radical sign. So here, for example, you happen to have the same number under. It doesn't have to be that way though. So I'm just going to take these two numbers and multiply them together to get 4. So all I have to do is take these two things under the radical and multiply them together to bring it into one radical. Now I can simplify this radical the way that I did before. So it's a very easy example. The square root of 4 is just 2. Anytime you have the square root of two things that are identical under the radical, multiplying them together will just give you that expression under the radical. So whatever it is, if you have the square root of 3xy times the square root of 3xy, it'll just be 3xy. So now let's try this example. Here I have the square root of 6 times the square root of 15. So I'm going to multiply the 6 and 15 together to get 90. So now I'm going to split that up into two numbers, making sure that one of them is a perfect square. So here I know that 9 and 10 multiply to give you 90. So I'm able to take a 3, or the square root of this number, out. I can't do anything with a 10, so it stays where it is. The other way that you could do this problem, once these numbers get a little bit larger, it's kind of annoying to multiply them. If you want to just keep them as they are, and just try to simplify them by knowing what their factors are. So for example, 6 is really just 2 times 3, and 15 is really just 3 times 5. So now because I have two 3's under the radical symbol, I know that I really have a 9 under there, which is a perfect square, and then I can bring that 3 out. And then I just leave inside the radical the other things that are left over and multiply them together. Either way, I get 3 root 10 as my answer. Sometimes when you have a radical expression, you're lucky enough to have one of them be a perfect square already. If you have that you have a perfect square there, then just take it out. So this was really 7 times the square root of 24. So now you have to simplify 24 by trying to find a perfect square that goes into it, namely 4. So now this becomes 2 times root 6, and that 2 combines with that 7 to give you 14 root 6. Now, let's try to do this example. So here I have, it's a little bit different because there's a number on the outside of the radical to begin with. So before we even worry about what's inside the radical, let's combine the numbers on the outside of the radical. So this expression can be simplified to negative 8 times the square root of 12 times 45 on the inside. Now if you want to multiply 12 times 45 together, that's fine. But they're such big numbers that it may be a little bit hard for you to know what goes into them. So I would suggest at this point to just break up each of these numbers to numbers that you know perfect squares go into them. Like 3 times 4 for 12, and 9 times 5 for 45. So now I know that I can take the square root of those two numbers individually, so they're going to come onto the outside. So I have the negative 8 there. I'm also going to have this 2 from the 4, and this 3 from the 9. I can't take anything else out, so this 3 and this 5 will stay on the inside and combine to give us 15. Now all we have to do is multiply these numbers on the outside to just simplify it. So 2 times 3 times 8 is negative 48 root 15. So now let's just try to do a couple of examples where we have a variable under the square root. So just like before, all you have to do is multiply everything together. You do not need to have the same thing under the radical in order to multiply radicals. So here, I'm going to multiply this to combine to 50x to the 5th. Now, I can split this up into 25 and 2, and I can break this up into x to the 4th and x. I can take out this 25 and this x to the 4th because they are perfect squares. And I get 5x squared times the square root of 2x. Now let's try this example. It's just a little bit more complicated. So here I have 24 and 6. If you want, you can multiply them all together, or you can just think about the numbers that make them up. Try to split them up into their perfect squares. So for example, 24 is really 4 times 6. And then 6 doesn't have any perfect squares that are in it, but however, it is a 6, which will combine with this one. Now I have x to the 6th and x to the 5th. That'll combine to x to the 11th. And y times y is y squared. So now I can bring this 4 out as a 2 on the outside. And 6 times 6 is really 36. Take the square root of that, it's really 6 on the outside. I can break up x to the 11th to x to the 10th times x. So I can bring up x to the 5th as the square root of this term. That x has to stay in there. Now, the square root of y squared is just y on the outside. So all I want to do is just simplify this and clean it up a bit, just by doing 2 times 6, which is 12x to the 10th, y root x. Now let's just talk about rationalizing the denominator. So before the time of calculators, the denominator needs to be rational so that a decimal approximation could be found. So now that we have calculators, we don't have to do all of the more difficult calculations that people had to do before there were calculators. Rationalizing the denominator is totally not necessary in today's world. However, the SAT tests and your HESPA test all require that your answers have a rational denominator. And that's really the only reason why we're doing this, so that you do well on your SAT tests. So now, in order to rationalize the denominator, all that means is we can't have an irrational number in our denominator. The square root of 3 or the square root of any number that doesn't come out evenly is irrational. So I have to get this irrational number out of the denominator. The way that I do that is using some of the reasoning we already talked about. So you have to think about what I could multiply this denominator by to make it a rational number now. So the square root of 3 times the square root of 3 is going to give us just 3. So I want to multiply that denominator by the square root of 3. However, if I multiply the denominator by the square root of 3, I also have to multiply the numerator by the square root of 3 so that this expression really equals 1. So now in the denominator I get 3, which is just what I wanted, just a nice rational number. And in the numerator I get whatever I get here, it's just 2 times root 3. The numerator is allowed to have a square root in it, the denominator is not. So let's just do one more example. So here I have 3 times root 10 divided by the square root of 5. So I always want to multiply by something that will make my denominator rational. That is just going to be the square root of 5. If I multiply it by the bottom, I have to multiply it by the top. So now in my denominator, I'm just going to get 5. And in my numerator, I'm going to get 3 times the root of 50. Now I have to simplify that root of 50. So we know that the root of 50 can be broken up into 25 and 2, and that this simplifies to 5 root 2. So now in my numerator, I have this 5 and this 3 to give me 15 root 2 divided by 5. But now 5 and 15 can be reduced into 3 root 2. And that's it for our lesson today. Don't forget to answer the questions.